Good evening. My name is Marcel. I'm the VP of Product from Shift Technology. How many people here know what a product manager is? Okay, there's a few reluctant hands. I'm going to give you a talk that's a little bit different. I think the two talks that we've just had were very focused on specific technical aspects of using data in building technology. My job is to take the technical possibilities, understand the market, and deliver a product that actually works for people in real life and delivers value to them. So I'm going to talk to you a little bit about what happens around the technology, how we build great products driven by data and AI. So Shift is a company that specializes in insurance. We build AI-powered solutions for insurance. I have to admit that whenever somebody says AI to me, I kind of recoil a little bit, my eyes narrow, I become very skeptical. It's a term that works very well in marketing. When you talk to technical people, it covers an enormous space. What I mean here is we use machine learning, we use natural language processing, we do a little bit of image analysis, and a whole bunch of data science in order to deliver solutions for insurers that help them deal with the large amount of data that they have and drive business outcomes. For us, we started as a startup. We started in fraud detection. So we have a product that helps insurers understand which claims should be investigated as potentially being fraudulent. And we're growing into an area that's rather new in insurance. It's called claims automation. Some of you may have had the experience of trying to make a claim with your insurance company. It can be very slow. It's slow because behind the scenes they have old IT systems, they have people doing manual processes, and it can take weeks, sometimes in the worst case months, for you to get an answer to your claim. So our mission is, how do we speed that up? How do we make your experience as a customer great? And how do we make sure that for the insurance companies, it's not a resource drain to have a decent customer experience? There's a really strong link between the two. If you want to do claims automation, you need to be able to detect fraud. Otherwise, you'll end up with essentially a system that is very, very fast at paying claims that you shouldn't pay. So this is something that happened in e-commerce when businesses went online. You get much easier customer experience, but you get a ramp up in fraud. So we think with our fraud expertise, we're very well positioned to help here, and we see a very strong link between the two problems. So what I wanted to talk to you today about is the relationship between these AI systems that we build and the people who use them. So when we talk about our products are never they're never systems that work on their own. Right? They're never big AI systems where you have data in and data out, and there's no human involvement. If you think about Facebook or YouTube or a lot of the things that are done at big tech companies, they're solving purely digital problems. I used to work at YouTube here in Paris, and one of the things we touched here was the YouTube homepage. And you have essentially, as input, a whole bunch of knowledge about the videos, a whole bunch of user behavior, and many more other factors. And the output is a set of recommendations about videos. And nowhere in that process is there a person involved. And so the kind of system you can build doesn't have to take into account that there are people that have to understand what's happening inside. By contrast with Shift, it's very different. We work with teams. You have a claim handling team that takes this claim statement from the customer. You have a fraud handling team that does some kind of investigation if there's a suspicion of fraud. And then you may have other people involved, like an investigator or a loss adjuster, who go out and get more facts about the case, in the case that there's not enough information to handle the claim. So these processes are very dependent on people. There's a strong interaction between the machine and the people involved in the process. And so we have to make sure that everything we do accounts for that dynamic. So this is my visual image of the classic machine learning system. You build a big system, takes in a lot of data. You do something very complicated with it, convoluted neural networks, or some other deep learning approach these days, and you spit out a result, right? Yes or no. You spit out some kind of score. In fraud in particular, that's historically been the approach. You take an object like a payment, a transaction, a claim in our case for insurance, you send it into a big system. The system takes in many, many features and makes an assessment of whether it thinks it's fraud or not. But the challenge with this kind of approach is that it's very hard to understand what's going on, and that makes it very hard for people to work with it. It's okay for the engineers who built it, but for the people who are actually consuming the output, it can be very difficult. So for us, we need to think of AI as a tool, not AI as a complete solution to a problem, but as a tool used by people to solve their business problem. And this really changes the way that we have to think about the products that we're building. So I've been at Shift for about a year, and we had a bit of a reflection on terms of startups are an interesting place to be. If a startup gets to a certain size, we're now about 200 people, it means you've done something right. And so you have an opportunity to look back and say, what actually was it that made us successful? And for us, we had to think about what is it about the product approach that's unusual. And we came up with 4 rules that we think, or 4 characteristics that we think are important if you're building a system which is AI as a tool. And so I'm interested to share these if people have feedback about them, if people have found them true about their systems. I'm interested to hear if there are other rules that you've found that we haven't discovered yet. But these for us are the characteristics of a system which is designed to work with people, but which is powered by AI. So the first one, probably not surprising, I've already hinted at it. It's about transparency. When you're presenting a tool that's powered by AI to a team, they need to be able to look inside and understand what's happening. So concretely from our domain, we give claims to a fraud team that we think is suspicious. And if we just give them a claim and say we think it's suspicious, but we don't tell them anything about why, it's very hard for them to know how to act. So what we have to do is we have to tell them what is our suspicion. Right? We have a suspicion that in fact this case of fire damage to a house was actually arson. Or we have a suspicion that this case of damage to somebody, an injury to a person, was from a staged accident, a fake accident that people had deliberately. And then we tell them why. We think that because in the case of a staged accident, the material damage to the car is very different in severity to the physical damage to a person. And usually there's many, many factors involved, which is where the machine learning, the AI part of it comes in. Right? So we are essentially identifying what are the characteristics that led us to believe this. And from a technical point of view, that means that one big system that just simply spits out a result is not a good approach. And in the end, what we've built from a technical basis is a system of many, many models, each of which are making a judgment about a potential fraud scenario, and which all contribute to an end decision as to whether we decide that a claim is suspicious or not. And based on which of those models is activated, we're able to say which suspicion we have and give a lead to the investigator who can then pursue that. Right? If it's a case of arson, the first thing you go and look for is what was the investigation report from the fire department. So this is designed in from the ground up, and it has to be part of the architecture of your product from day one, if you need it in your product when you launch to real users. It has another consequence as well, and it goes a little bit in the direction that Arno was talking about. There's a lot of machine learning these days that's done on unstructured data, and you don't necessarily need to understand your data very well, as long as the machine can make sense of it internally in your models. You don't necessarily need to be able to explain the structure that the machine puts on top of the data in order to have a successful machine learning system. It's not true if you want to explain to your users what's happening. Right? So one of the things we've had to do at Shift in understanding insurance is build a model of the world that's very complex and rich enough that we can detect these very numerous different types of fraud and be able to explain them to our users. So we have a kind of taxonomy of the world, of insurance policies, of fraud, all the things that we need in order to build a system which is explainable and transparent. It's a similar challenge for us when it comes to claims automation. If you want to make decisions about claims, you need to be able to explain why. And so we have to have a very structured approach to machine learning. The second principle is control. And whenever you talk about computing systems, these two tend to go hand in hand. When we talk about privacy, we talk about transparency and control. When we talk about AI, we talk about transparency and control, because it's one thing to be able to tell what's happening inside, but as soon as you see what's happening inside, as a user, you tend to want to be able to change it, right? To make it behave in the way that you want. So for us, it's important that our systems are manageable by the teams that they serve. Right? It's supposed to be a tool for the team. If they can't control the way the tool is behaving, it's not going to be as useful to them. So an example from fraud, we found early on that we're generating alerts for our customers. We're telling them which claims that they should investigate, but they also have their own other sources of information. So they get calls from the police or from other insurers. They have somebody internally saying, hey, you may want to have a look at this claim. So even though we've missed it, they know that there's something worth looking at. So we realize that in our system, we need a way for them to tell us that. Right? They need to be able to tell us, in fact, your result there was a false negative. And then we can still bring value, right? Even though we didn't detect it, the tools, the data that we present, the workflow that we have can still help them to manage the investigation. So we need them to be in charge of the ultimate verdict, not us. And for claims automation, control comes in the form of being able to take over from the machine. Claims automation is a very complex problem. When you're dealing with a claim at an insurance company, there's many, many steps involved. There's many decisions to make. And we know that our system on day one is not going to be good enough to make all of them all the time. And so somebody has to be able to say, I'm not happy with the outcomes, or I'm not confident that the machine is making the right decisions. I want to take over. We need to be able to give them control of the process. The third principle is integration. I think sometimes we imagine that we can build a system, we have our input, we have our output, we really don't have to worry about anything else. In practice, if you work with businesses, in our case large enterprises, you're normally working with people who also have other tools that they want to use. And if you haven't thought about the way that your tool has to connect with the other tools in their life, they're going to have a bad experience. Right? So as a user, maybe they have an internal information system that they have to have access to at the same time as your tool. You need to think about that in terms of how you design your product. But most fundamentally, if you want to build a system which is driven by data, you need a way to get that data from your customer and return the results. And this, honestly, is the death of many an insurtech company, because it's hard to work with insurers in a technical sense. They have an IT team who may not be particularly quick. They may tell you, yes, we have budget for that next year, and you have enough cash to get your startup through till next January. So honestly, the real problem in working with insurance companies can be just getting a connection with their internal systems. So for us, in retrospect, one of the things that made the business successful is that we figured out a way to integrate with insurance companies which was relatively lightweight. So we get a daily transfer of data from the insurance companies. It's not technically whiz bang. It's a CSV or an XML file that they send us every day, once every 24 hours. But the great thing about that is that they know how to do it. They do it for other old-fashioned integrations. And once they've set it up, nobody has to touch it again. And when this is really important, when you think about if we had have given them an API which had a bunch of fields that we asked for, it would have taken them a long time to implement it because they're not used to dealing with that kind of thing, because it has its own specific requirements unique to our product. But the big problem we would have now is every time we wanted to add data, we would have to change our API and expect changes from their system. Because they simply give us a data transfer of their databases, we have the data that we need to innovate, right? To find new kinds of fraud using different approaches. So that very basic approach to integration has served us really well in working with these kinds of customers. Even more basic, it is possible. In claims automation, when we started working with our first customers, we realized that we could analyze the claim and tell them what to do, but we had no way to write it back to their system. So the best decision in the world, the best AI in the world, is useless if you can't tell the insurance company ultimately what to do. And what we did is actually a human integration. They already had people who were entering into their internal system information about the claim. So we simply gave them the information about our decision, and they wrote it into the insurer's system for us. So there's a human API between our product and the internal system of the insurer. But it's enough to get started, right? So it's enough to show that we can add value and to prove that we're making the right decisions. And the last principle is humility. I'm actually not the biggest Star Wars fan, but it's a theme we often use at our company. We have products called Luke and Force. I think from as much as I know about Star Wars, Darth Vader is the epitome of a lack of humility, right? Failure because you overestimate yourself. And AI systems, the canonical failure is you have an answer, but you shouldn't, right? You're making a prediction and it's incorrect, and that can have either embarrassing or quite serious consequences. So it's really important that your system is able to say, I don't know. Right? If you're able to, instead of just saying yes or no, you're able to say yes, no, I don't know. You can really have a different approach to accuracy. Right? You can lower the recall of your system. You can not take decisions in order to increase the precision. And we can do that in our context because we're working with people. If our machine doesn't make a prediction, we can give the task to a person. That's what they were doing before anyway, and they can fill the gap. So when you're working with people, always keep in mind that you need to be able to say you don't know rather than making a mistake. And there's somebody there to back you up, which is the team that you're working with. And that's really important for us because when you talk about insurance, we're making decisions that impact people's lives. Right? They're making decisions about whether to pay a claim or not, whether to investigate for fraud. And so it's really important that it's accurate. Right? There's a very high demand in terms of precision. And so being able to say we don't know the answer enables us to fall back on human experts who do. So I told you at the start that when people talk to me about AI, artificial intelligence, I tend to be a bit skeptical. But I realized after reflecting on all this that this idea of thinking about the computer as a person is actually kind of useful. Because when you put these characteristics together, I think what you're actually describing is somebody who's a good team member. Right? When somebody joins a team at a company, how do you want them to behave? Right? You want them to be transparent. You want them to tell you what they're doing. You want to be able to control them. You want to be able to influence their decision making and guide their work. You want them to be part of the team and use the tools that you use. And you want them to be humble, right? You want them to ask for help when they need help. So in a sense, this is one of the first places where I'm really convinced that this idea of encapsulating what we do with machine learning and other techniques as being like artificial intelligence is kind of useful because the behaviors really map to human behaviors. So I found this as a really interesting concept. Sorry, we've started talking about this as the human-computer relationship, not just interface. It's not just about how does the screen look. It's about how does the computer work with the people. And the other sense in which this is a relationship is the fact that it changes over time. So normally when we launch our product with a customer, particularly in claims automation, we take on a particular scope. We might say we're only going to deal with claims that have water leaks. We're not going to deal with any other kind of claim. And on those claims, instead of giving our decision directly to the customer, we're going to give it to the team for a while until they're confident, and then we're going to give it to the customer. And so we're able to adjust the scope that we're working in based on the confidence of the team that we're working with. And so we have a relationship, in fact, that changes over time. It's not as though we take what they're doing and we just completely replace it by a computer system. We do it very gradually based on that dynamic. And so I think thinking about the relationship between your product and the people who use it as a relationship, as something that can change over time and which has some kind of human characteristics, is a useful way to think about how AI products can serve teams, particularly within companies. Thank you.
Thank you, Marcel. Any question? So I'm going to start. Basically, I'm pretty impressed about the maturity of designing and enabling the AI to have a better human-computer relationship. So, do you have any background about shift last 3-4 years to have this kind of maturity, because it's not usual to understand all these key points about transparency, integration, and so on. So can you feed us about was it a easy way to work with your clients and say, okay, because you do this kind of business, you have to be the transparency is compulsory? And can you explain us how you
did we
improve
arrive
the
here?
way?
Yeah. So I've only been at Shift for a year. I spent a long time building products at Google. And I guess for me, Google is a company that tends to think about things conceptually. So maybe some of the way we talk, or the way I talk about this now, is a little bit from that background. But I think the main point is that Shift as a company has grown very quickly especially in the last year or two. We've gone in the last year from about 100 to more than 200 people. And with that kind of growth, you really need to have an active handover, an active transfer of knowledge. And our founders, particularly our head of research, is somebody who thinks about the world in a very structured way. And so when he was handing these kind of things over to me, there was already a kind of intellectual framework for what we've done. He had a lot of insights about how to understand how we arrived where we are. But I think this is a good exercise to go through for anybody, right? I think this idea of sometimes in the Silicon Valley world, people like to say that they succeeded because they're brilliant and they worked really hard. But often they succeeded because they were in the right place at the right time with the right idea for reasons that were entirely unconnected to them. And I think it's very, very important for a company to do that analysis and say, like, what is it that made us successful? And I think the folks at Shift, particularly the leaders, the founders, have been very realistic about that. Right? We arrived at a time when insurance companies were just dipping their toes in SaaS. We arrived at a time when they were starting to understand that AI and machine learning might be important to their future. And we arrived at a time when they had seen the transformation in financial companies like banks and understood that it would come to insurance. And so this process of reflection, at least at Shift, seems to be quite like an active and constant part of the company culture. But I would definitely encourage, I think if you're an entrepreneur and you've had some success, I'm sure you're brilliant and I'm sure some of it is due to your talent, but really reflect on what were the key things that made you successful, because it will help you for the next, when you want to build your next product and find your next set of customers, it will help you to understand it.
Great.
Yes, I think like all startups in Paris, we're hiring, particularly in data science. I'm looking for a product manager and developers. Excuse me? It depends on the field, but I can point you to our website.
Hello. Hi.
Hello.
So, if I were to make a claim, I wouldn't want an AI system to, work for me and, maybe make a wrong decision. So, there's this issue of trust too, right? So, do you think this system can ever be exclusively AI and not include humans at all?
Can it be exclusively AI and not include humans at all? Yeah, in the future? In some cases, potentially. So we're already in a situation where we're able to make offers to customers and they accept them and they seem happy with them. That doesn't mean that all the offers we make are accepted or that all the customers are happy. And so feedback is really important, right? Understanding whether customers are satisfied and whether our customers, the insurers, are satisfied. So we actively create the feedback loops. I think I entirely agree with you from the point of view of looking at today's technology and today's experience. I would have a certain suspicion if you told me your mortgage application is going to be treated by a computer. But it really depends on what happens, right? If I get an offer back in 30 seconds that says you can have a loan, the loan that I was looking for, then there's no real problem, right? And in practice, what tends to happen is that insurance companies, and I guess banks and many other companies, the main thing they're looking for is a way to treat the customers that they think are good in a very positive and fast way, while separating out the ones that are bad. And today, effectively, they treat them all in the same way, right? If you're a good customer with an honest application, you get treated the same way as a bad customer with a dishonest application, and you have to fill out all the forms and jump through all the hoops. So I think where people will very quickly feel the benefit is being treated as an honest, good customer when you are an honest, good customer. Final decisions, I think important final decisions will rest with people for some time, but we're already able to tell people, you've had a water leak in your house, you need to repaint one wall, we can offer you 300 euros on the spot and you can do it yourself. Do you want it or not? It's your decision. People are pretty happy with that kind of outcome.
When you use AI in insurance, one of the issues is that you might individualize, in fact, risk, and so there's no more mutualization between all the different people. How do you tackle that? Because on one way, either there's no risk, so people won't buy it, or there's so many risks, so the premium is really high to impact the financial risk.
Yeah, that's a really good question. It comes up every time people talk about underwriting. So for us, actually, most of our work is in claims. So detecting fraud in claims, automating claims, where that's not really a problem. I mean, there are other problems to do with bias and so forth, but that problem mainly comes up in underwriting. And so we work in underwriting fraud detection, trying to identify, for example, if you're making an application for a car insurance policy and you're 18 years old, but you say you're 27, can we help to detect that? And clearly, the parameters that we're working on, again, like feeding a big system with a whole bunch of data and hoping it does the right thing, is probably going to lead to bad outcomes. So we're working in the same way we have in claims, which is to take a very structured approach and to be confident, like when we're applying models, confident about the behavior of the model and the meaning of the outcomes. But there's a huge, I don't have an answer for your question because it's a huge discussion. Every time you go to an insurance technology conference, the question about how AI should work in pricing or making decisions about insurability, it's a huge question.
What would you say is the failure rate of this system?
It's a very general question. It depends on the context, the claim. What we talk about in fraud in general is that we have a 75% hit rate, which means that 75% of the alerts that we send, the fraud handling team thinks that they're worth investigating. So for them, that means they're not wasting a lot of time reviewing alerts that are not useful. And you'll see, I think if you look across solutions that do this kind of thing, you'll see similar figures, right? The 85% of alerts from Arnaud, it's a similar kind of principle, right? You're trying to find the right balance between precision and recall, and 75, 85 is probably about the right trade-off for many different contexts.
One last question. We're good? Thank you, Marcel.
With pleasure.